This problem involves just doing a little bit of algebra, so see if you can try this one. And of course, you're going to have to use some identities and substituting things in, but see if you can do this one on your own and then come back and check out the answer. Okay, the first thing I'm going to do is I'm going to substitute tangent squared of x plus 1. I know that that's secant squared. So this right here is secant squared. So I've got secant squared of x times, and we'll take baby steps, cosine squared of x minus 1 equals negative tangent squared of x. Now I might go off to the side and say cosine squared of x minus 1. Sine squared of an angle plus cosine squared of an angle equals 1. If I have cosine squared of x minus 1, that means I got the sine squared to the opposite side. So I subtracted sine squared, and then I subtracted 1. So I have cosine squared of an angle minus 1 equals negative sine squared of the angle. And that angle is x. So this right here is negative sine squared of x. Let me put this in red right there. There we go. So this red became that. And this blue is going to become negative sine squared of x. So we have secant squared of x times negative sine squared of x, and that needs to equal negative tangent squared of x. So I feel good that we've got our negative there, but the secant squared is confusing the issue. What do we know about secant squared? Well, secant is the reciprocal of cosine, so we can make this 1 over cosine squared of x times negative sine squared of x. And when we multiply 1 over cosine squared times sine squared, we're going to get tangent squared. So we have negative sine squared of x over cosine squared of x, which gives us negative tangent squared of x, which is exactly what we needed on the right-hand side of the equation.